Hello, I'm Ibrahim Imam, and welcome to another episode of the Neurology Lounge podcast. In this episode, we will continue our exploration of cluster headache, and I'm joined by Amanda Ellison to discuss the part of her book titled Splitting, which comprehensively and exhaustively covered various dimensions of cluster headache, some I've never even thought about in the past. Amanda Ellison is a neuroscientist and physiologist. She's a professor in the psychology department in Durham University and former director of the Wolfson Research Institute for Health and Wellbeing. She's interested in understanding how different brain regions communicate to create our behavior and how we experience the world around us. And she's particularly absorbed by the reciprocal influences between the brain, the body, and behavior, and the biology that binds them together. I'm intrigued about this, and I might ask you to explore this a bit at the end of the podcast. Amanda Ellison has addressed many diverse questions, from how we can restore function after brain damage through rumination, addiction, and hallucination, to headache, pain, and aging, always with interdisciplinarity at the core of our approach, which I think that's kind of summarizes the theme of this podcast. Amanda Ellison, thank you very much for joining me on this episode of the Neurology Lounge podcast. I'm most grateful.
It's an absolute pleasure to be here. Thank you so much for the invitation.
So your book Splitting is obviously more than just cluster headache, but what is your interest? Why did you write this book on headache?
Well, I've always been interested in headache, and because of various past incarnations that I've had, I've been interested in how it is the research that I do in the lab actually would relate to headache and the experience of headache, but also what's going on in the brain and how different areas are communicating and how that might be faulty to bring about the experience of headache. And one of the bugbears that I had before I wrote the book, I still have it, but the bugbear that I have is that people tend to lump all headaches together. So whether or not you've got a stressful week and you've got a headache because of that, people often say, oh, I have a migraine, when actually it is not a migraine. The migraine is a very specific form of headache with a very specific neuropathology associated with it. And a stress headache is nothing like a migraine headache. And so my major bugbear is that there's a big misunderstanding out there about headache, not just within the public, which you might expect, but also within the medical professions. And so delving down into that a little bit more, you realize that there is a big disconnect between what it is that we know as neuroscientists in the lab and what actually gets translated into medical practice. And that's something that's prevalent across many different aspects of my research. But for pain and for headache in particular, it is quite poor. You talk to GPs, you talk to people who are doing medical degrees, and they'll say, we don't spend long on this during our education. We spend maybe 20 minutes talking about pain. And the reason why is because we have many ways to combat pain. We have opioids now. We have ways of making you switch your brain off to pain. And as you know, opioids are not the answer for pain, certainly not the long-term answer for pain. But in a way, our means of spending time educating our next generation of health professionals is very much linked to whether or not there is a solution, right? And if there's a solution, we don't need to spend time on understanding it because there's a solution. We have a tablet, we have something, a medication, we have something that we can do for that. And for headache and pain in particular, spend 20 minutes on pain, maybe over the course of your education for a medical or medically related degree, or undergraduate or even postgraduate. But for headache, it's even worse, right? Because we just see headache as being a form of pain. Here, take a painkiller, and that can be, a non-steroidal anti-inflammatory, or, as it ramps up, it may be something that switches off the central nervous system, maybe, as opposed to the peripheral nervous system. And what we miss here is that understanding of where the headache comes from for the patient in front of you. And of course, you have 7 minutes as a general practitioner. You don't have long to get into that history, to get into that, okay, why are you experiencing this headache? You as a healthcare professional, what do I understand about the triggers for headache? What kind of headache is this? How would I approach it? And not having that segmentation or that understanding of the segmentation between the different types of headaches can hamstring you as a health professional, because you might think that all headaches are the same, or you might just think all headaches are migraine. But as you know, you would actually treat a migraine differently to how you would treat a stress headache. So understanding the etiology for each patient is really, really important. And so that's why I wrote the book. I wrote the book in order to give the general public an understanding of that segmentation so that they were more informed about their own experience and their own life, and how that then feeds into their behavior, their biology, and ultimately their pain, and the things that maybe they can do to approach it. Certainly not in a self-help way, but in a more, let's try and develop your understanding of your experience as a human, and then that will actually help you address your life when things go wrong, particularly with respect to headache.
And I suppose the more the patient knows about these things, the more they can nudge their doctors to.
Absolutely. Yeah. And I think that generally, particularly post-pandemic, and given the pressure that we have on being able to actually see a GP, actually empowering people to know that actually there are very, very simple things that they can do. And it's not because headache isn't complex. It is. And all of the headaches that we experience are generally they don't fall into one box or the other. So it really is about understanding the whole of your life, and it's your responsibility, because your GP has 7 minutes and they are not clairvoyant. They cannot read your mind. They can't see through your soul. They can't suddenly touch you and get a flash of everything that's going on in your life. So really it's about us taking responsibility as humans to try and understand our experience within our environment and help ourselves a little bit more.
Okay, that kind of covers what I felt when I was reading the book, and I suppose you had to go out of your way to make sure the language was easy because complex topics, genetics and all that. You had to kind of go out of your way to make sure you simplify the language. How much time?
Yeah, it's really interesting. It's the second book that I've written, but this one was certainly for what we would call a trade audience, so just for the very general public. And my whole mantra is there is a way of conveying complex things by engaging people and engaging the story, engaging them with the story and making it relevant to their lives without dumbing it down. Right. But it is a very, very fine line. And so as scientists, we rely on our editors. The book would have been a heck of a lot longer had I had my way. There's lots and lots of different stories that I would have put in, because to me, science is the greatest story that there ever was. There are such wonderful things, and yes, they're complex things, but oftentimes the most interesting thing is how us humans get involved in that story, and the story behind the science, and how people start to think about things that have absolutely changed our world. And those are the things that I find really very interesting, but actually don't come out as much in the book, because my editor said, that's not relevant, you must stick to the story. And of course, we all as authors are under that particular caution. So there's lots of things that I had to leave out.
Yeah, they don't want the book to be bulky as well.
Yeah, exactly. Yeah. You do just need something that's nice and succinct, but the color parts of it and various of the things I managed to get into the end notes in the book. So I encourage people to read those, because that's often where the personality of the story lives.
Comes through. So, I mean, as you said, you didn't just talk about the science of the headaches. You went back into the history, and my first few questions actually,
by all means,
came across how we eventually ended up with the name cluster headache. And you said it's a disease that has been given many monikers, and first one is a bit of a tongue twister: erythroprosopalgia of Bing.
Of Bing. It does. It sounds really sci-fi, doesn't it? So I'm very, very keen to break down all the terminology, because I think that terminology, particularly in neuroscience, turns people off. But when you talk about the etymology of where the words came from, then it doesn't seem so daunting anymore. And it brings people into the story and empowers them to actually unleash their understanding on it. So erythroprosopalgia of Bing, right? Erythro is just a redness.
Yeah.
And prosopo is of the face.
Okay.
And algia is pain. So we put that all together and we've got erythroprosopalgia of Bing. And the only reason it was called Bing was because it was Paul Bing, Paul Robert Bing, who was the person who came up with it. So, it's all something that allows us to break it down and work out where it is that might be happening, and tell us something about the experience of it. And as we know, when you're experiencing cluster headache, you do get a redness of the face with pain. So, but that's less catchy, is it not?
Yeah. One would think it explains cluster headache better than cluster headache itself.
I think you're right. I think it does. I mean, there's many of the monikers that might explain it better, but I think if you think of the periodicity of cluster headache and how they tend to cluster in time, and that being the main diagnostic criteria now, I think cluster headache tells us something. It tells us something about how it's experienced in a sense of when it's a temporal sense, but it doesn't actually tell us where or what's actually happening. There are other names for it throughout history that do that better.
Yeah. As a neurologist, you're kind of faced with the patient with the first episode of cluster headache, and I guess you don't have the benefit of the history of periodicity. So I will remember erythroprosopalgia.
It sounds very famous, doesn't it?
And then Wilfred Harris came up with this migrainous neuralgia. I think is it under the thinking that it's a form of migraine, is it?
Yeah.
Was he?
And it's really common for people even today to think that the cluster headache is a form of migraine. So Wilfred Harris, he was a British neurologist. He wrote lots and lots of books. He was really, really interested in the trigeminal nerve, but he conflated the neuralgia, or the inflammation of the nerves around cluster headache with migraine, which was unhelpful, I think.
Yeah, migrainous neuralgia doesn't do just. Yeah. And then Horton's cephalalgia came in after Wilfred Harris. And what was his story? What was his thinking about?
Bayard Taylor Horton. So he described its pathogenesis in 1939. He was an American. He did lots and lots on headache. And he comes back into the story a few times, and because he was thinking about headache as being, well, certainly cluster headache as being mediated by histamine.
Yeah. We'll come to histamine later on, and it's still relevant, isn't it? Okay. And then what you described as the most anatomically descriptive moniker is sphenopalatine neuralgia.
Yeah.
What is so
So whereas we think that cluster headache is a good name for cluster headache because of the periodicity, but of course at first glance, you have to wait for the periodicity to happen. What sphenopalatine headache might help us with is actually being able to define where the pain is coming from. So the sphenopalatine, a group of nerve cells that are connected to the trigeminal nerve. And so by thinking that there is there is inflammation or misfiring there, then you've localized it to a place in the head. But actually, to me, it's a little bit too narrow, because it doesn't actually encompass the entirety of the experience of cluster headache, and it makes you think that it just happens from a very tiny place, right? And of course, it may begin that way, but we now know that it's much more biophysiological. There's a much bigger biophysiological mechanism, probably governed by the hypothalamus, which of course has its little fingers in every body of our brain and our body and our behavior. So it's a little bit too narrow for me, that one.
But probably appropriate for its time, I guess.
Yeah, agreed. Because, it's interesting, and we know that when we look through all of these things through the lens of history, you see that there are some people who are lateral thinkers who try to encompass lots and lots of different etiologies or causes or effects into their description of pathologies. And then there are some who are very narrow, and they go, oh no, there's something wrong with this nerve, and you're just like, well, okay, that's a bit too narrow for me, because it actually blinds you to everything else that may be happening.
I guess.
Spoken as a true lateral thinker.
Yeah, I guess it's the engineers and businessmen who get into medicine who want to identify these specific. And then Edward Charles Kunkel came up with the name cluster headache.
Yeah.
It's amazing. His name, you would think it should be a very popular name, but I don't think it rings a bell with many people.
Yeah. So Kunkel is less famous, really. So he coined it in 1953, and eventually it got some traction by the 1970s, 1974 in to be precise. And because in 1974, Otter, I don't quite know how to pronounce this, Sastad, who is Norwegian, who's a Norwegian neurologist, he started Cluster Club, which is quite catchy. And this was a club of neurologists and health professionals that were interested in cluster headache as its own separate syndrome. So he got a bunch of people together in Uppsala in Sweden in 1974. It coincided with the 10th annual meeting of the Scandinavian Migraine Society. Now, you have to bear in mind, in the mid-20th century, there were societies for lots and lots of different things. And nowadays, we know that the big daddy of all of our societies is the Society for Neuroscience. So that, pretty much encompasses all of these things. But at the time, you not only had Cluster Club, you had the Scandinavian Migraine Society, you had headache societies, you had American societies, you had European societies, many European societies, and they all had their own little networks. And I think Otter was a visionary in that he realized that what we needed everybody to get together, and we needed an international society. So we needed an international headache society. There was an American one, there were various European ones, and he realized that we needed to get them all together. So he did start Cluster Club, met every year in various places, and generally it coincided with meetings of various other things like migraine trust meetings or headache society meetings from wherever they may be. But Otter was very, very keen to establish the International Headache Society. And I didn't get to go into it very much in the book, but he did by a little bit of skullduggery in that people were not on board with this idea. They really were not. They were very worried that you would upset the established learned groups, right? And they just thought it would be okay to work fruitfully under the separate regional assemblies that they had, okay? But we know that people become siloed, and that rarely works. And the one thing that drives me nuts as an interdisciplinarian is when you have a reinvention of the wheel. So I might find something out in my lab, but because I'm not talking to a lab in Africa or America or Asia or some other place, they just go ahead and they do the same thing again. And of course, this is made worse by the way that we publish our findings. We're not particularly encouraged by the system to publish negative findings, right? So all those things that I've tried that haven't worked, and I use that term advisedly, because to me, there's no such thing as something that doesn't work. A finding is a finding. It tells you something. It needs to be plugged into a narrative of what it is that we know in order to inform the next question that we ask. But I digress. The point I'm trying to make here is that if a lab in Africa or if a lab in America or Asia doesn't know that I've tried this thing and it hasn't been as fruitful as I might have expected it to be, they may be wasting their time trying the same thing and not finding anything fruitful as well. And so that drives me nuts. So I think that communication, particularly in terms of interdisciplinarity, but also in terms of disciplinary work as well, is hugely, hugely important. And our publication system isn't actually the most amenable way that we should do that. Meeting people is, right? So meeting people, gathering together in Congress and talking to each other about, oh yeah, I tried that doesn't work, that kind of thing, just in conversation, in less formal conversation, that really, really works. And this is something that Otter realized. Compartmentalizing is fine, but you can't understand a part of something until you understand all of it and where it fits in the general narrative. So involving the wider expert academies across the world is vital, not just in terms of our efficiency, but also in terms of being able to mine all of those different viewpoints and move us forward in ways that we may have been moved before. So what Otter did in 1982, he took the reins into his own hands and thereupon ruled in an autocratic way. What he in effect did was he pretty much stood on the back of the subcommittee that had been established, and none of them could agree. But there was a subcommittee to say, should we have an international headache society or should we not? And they just kept fighting in amongst themselves. And what he did was he pretty much got people into a room at a meeting of the London Headache meeting in 1982. There were about 20 to 25 people there, and there were people standing in the aisles and standing at the back and everything. And he thought, oh, there's going to be trouble here. And what he had done was he had seeded the room with a few people that would help him if there was trouble, right? And he was expecting trouble. And of course, people were hungry, people were hangry, He took a really very, very simple approach. And he knew that the first words that he said would have to be crystal clear and leave no room for brokerage. Otter stood up, having gone on for a little while. And he said, we came here to form an international headache society, didn't we? And of course, that is why people were in the room. Not that anybody really wanted to do that or they had a vested interest or, they didn't really know that would be the outcome. But people went, well, yeah, that's why we're here. And he said, well, I'm very glad for your support. And that was it. So he basically said that the first yes always tends to lead to more yeses. But you need to establish that first yes. So in that 5 seconds, the IHS, the International Headache Society, which we all now know and love, was formed. And then, of course, because he had this almost carte blanche, he could go ahead and then create a committee. He didn't stand for its presidency because, as far as he was concerned, his work there was done. And they met later on in Munich, and they democratically elected Eero Hokkanen from Finland as their president, and it's gone from strength to strength from then on in. And cluster headache was brought under the International Headache Society because there was much more recognition of it as being its own pathology within the headache literature, and so we didn't need to have Cluster Club for it anymore, a dedicated forum.
So it kind of validated cluster headache, isn't it, coming under this big
Absolutely, yeah.
A lot of lessons from that story, but I guess the key one is it's not enough to have a vision. You really have to have a way of implementing it.
Yeah, you absolutely do. And I think that's where a lot of what it is that we do falls down, as you've built your theory of how something works empirically, then that does need to be tested. And I think that this is where interdisciplinarity sometimes falls down, in that you may have a vision of how you think something would work in practice, particularly that translational leap between the laboratory or bench science, or even desk science, desk research, into implementation. And you can have a vision of how it works, but if you don't bring the right people on that journey with you, with the right voices, and I'm including patients in this, because you don't want to spend 10 years of your life developing an intervention for a patient, only for a patient to turn around and say, I'm not using that, which of course has happened to engineers and computer scientists before. So we need to build these interdisciplinary teams to look at the problem from all the angles to make us a lot more efficient in the efficacy of our interventions.
Okay, we've come back to the theme of interdisciplinary
sure.
action, which is very powerful. Okay, we'll put the history aside for a minute and kind of delve into the clinical aspects.
Mm-hmm.
And I think your first contact with cluster headache, you said, was this lady called Rachel.
Mm-hmm.
Tell me about that encounter. What did you make of it at the time? It's kind of a new field for you. You hadn't been involved in cluster headache then. What was your
thinking? I really hadn't. I was aware of it, but I'd never experienced an interaction quite like this before. Just to add some colour, I was working in the Department of Experimental Psychology in Oxford. I was postdocing there, and I had just stepped into the lift, and the lift was where the cafe area was. And I just stepped into the lift and pressed the button, and the doors were closing, and I literally saw this girl, 18 years oldish, and she was actually just banging her head against the brick wall. And I thought, oh, there's something wrong here. And the way you initially, when you see somebody who's having a crisis, you kind of think to yourself, should I approach, or is that going to make it worse? Should I approach? And then I was very selfish about it. I said, well, listen, I can't live with myself if I don't approach. I just have to see how it is. I didn't want to upset her anymore, but I needed to satisfy myself that I had done everything that I could. So I approached, and she was in bits, in absolute bits. She was crying, she had a droopy eye, just tears. And I just said, what's wrong? I honest to God thought she'd fallen down the stairs, or she'd been attacked, she'd been punched in the eye, something, but she just said, I have the worst headache I've ever had. I think I'm dying. Nothing I do will work. And so I said, have you taken painkillers? Which seems very trite. She was in an absolute state. And to actually say, have you taken some paracetamol? She may as well have taken Smarties, So she was just she couldn't sit still. She was really, really restless. And she was, I would call it very anxious and tense. I could tell that there was something going on, and it was the droopy eyelid, the fact that she sounded like that, the blocked nose, the fact that her face was very flushed, and something in my head just went, cluster headache. And I said, have you experienced this before? And she said, no, I haven't. But and obviously you also think of like the really nasty things, like a brain bleed, an aneurysm, something like that. But either way, it was pretty clear that we needed to get her some medical attention. So eventually we got her to a GP. Thankfully, her GP wasn't too far away, but I bundled her into a taxi and sent her off. I was busy in the lab and couldn't get away to go with her. But I did write a note to the GP because her symptoms had dissipated over the time that she had spent with me. She'd sipped some water while she was with me. So I wrote a note and said, these were the symptoms, because they actually wore off quite quickly over the course of about 20 minutes. In that she didn't have that droopy eyelid anymore. Her flushness was beginning to regulate. that kind of thing. So I was afraid that actually the GP wouldn't see her in the acute state. And you know, it's so difficult when people tell you what their symptoms were. So that was my first interaction with actually seeing somebody go through cluster headaches. So it's really arresting. It really, really is. It is widely defined as being the worst headache that anybody can experience. And I think we know that there are really bad pains that people can experience. So toothache is right up there, and earache is another one as being like the worst pains that people can experience. And if you know anything about gating theory, it's that any pain that's coming from your body up to your brain, there are many ways in which your brain can switch off to the signals. But of course, if you have things happening in your head, or you have things happening in your ears or in your mouth, the ways in which you can gate that pain are lessened, because there's very little distance that the signal has to travel to your brain. And so there's less opportunities for you to gate that pain.
Because a lot of gating happens in the spinal level.
Absolutely. Absolutely. Yeah. And so if you think about, you know, if you have a headache, or if you have something going on with your trigeminal nerve, which is you know, in and around your head, if you have something going on with your ears, or if you have something going on with your teeth, you don't have that, all of those different mechanisms that you could actually bring to bear.
Yeah, so it's maybe other moniker for cluster headache is, I think you mentioned, suicide headache. That kind of tells you.
Yeah. And I think that doesn't help with the anxiety of it. And we know that there's a definite interaction with anxiety in pain. So if you have somebody who has worked themselves up into a conniption because they think they're dying, then that's not going to help them self-regulate the pain. And I think that one of the interesting things about the role of oxygen, for example, because we now know that oxygen is a good treatment for cluster headache. And we know that this calms down the parasympathetic nervous system. It has direct effects on the trigeminal nerve. But if we think about it in terms of what's actually happening when somebody is experiencing such piercing and unrelenting pain, is you get a huge anxiety, also immune response to that. And so you can't tell somebody who's in that kind of pain to calm down. Right? But what they are doing is they are breathing more shallowly. They are not taking in as much oxygen as they ordinarily would. And so your musculature and your nerves are working anaerobically. And of course, that then feeds into the threat aspect of your body thinking it's under attack, and then taking even further anxious responses to that. So actually, what oxygen does is it helps break that sympathetic fight or flight response to all of these aspects, and just allows you to reassert control, because that's in effect what your brain is trying to do. It's trying to reassert control.
That's an interesting perspective. I will pick you up a bit on oxygen later on.
Sure.
Some exciting bits about it there. So you said Rachel had a pretty classic presentation of the disease.
Mm-hmm.
What else makes a classic case? I know we've talked about her droopy eyelid, the nostril.
I think that the periodicity is also something. So like if somebody's experiencing a cluster headache, and it can happen numerous times in the day and wear off, and it can just like be almost like a storm. But over a number of days, this will be something that will put it into a more classical presentation. Also, the fact that they very often happen in spring and in autumn. So as the light levels start to change outside, so like now is a particularly dangerous time, because the clocks went back for us over the previous weekend. And so, you know, we noticed that that's been done obviously for to give us brighter mornings for a while anyway, to stop little kids going off to school getting knocked down, which I think was the original reason why it was instigated. But actually, it's something that does play with our retinohypothalamic pathway a little bit, and we'll probably come back to this down the road. But that is something that then can affect our entire physiology and can affect our behavior because of that. Because evolutionarily speaking, that's our signal to go hibernate, you know. And of course, that's where seasonal affective disorder comes from and all of that.
Okay. Well, I mean, there are other issues that will come up to kind of describe what this classic presentation is. Then you talked about the non-classical manifestations. As a neurologist, what should one be looking out for with the non-classical?
I think it's possible to have a cluster headache that doesn't cluster as much as you might expect. Okay, so you might have somebody who is experiencing a cluster headache, and this is very much dependent on the self-report that you have to rely on as a neurologist, right? So somebody feels like they have had the same headache all day, when actually it's been more episodic than that. They're saying they had a headache all day. You're thinking to yourself, well, that's not a cluster headache then, because a cluster headache comes and goes. But people don't report it in that way. They say, I had a headache all day, right? Because first of all, that sounds worse, right? And they want help. And of course, that's how they're going to report it. They don't realize that saying that it comes and goes actually helps you as a clinician, you know? And also another reason why I wrote the book is mainly because people feel very alone in their headache experience, and they feel like they're the only people who have ever experienced a headache like this. And because it's happening inside of their heads, they don't feel like anybody else will have an understanding of how it is that it feels for them. And that's really, really difficult. So I think that by explaining a headache to you as a headache that happened over the course of a day, that can be less useful for you to be able to identify it as a cluster headache. For a clinician, being able to distinguish between, say, a migraine and a cluster headache, the biggest distinguishing factor that I came across with patient groups that I spoke to was that migraine was often described as a pneumatic drill that was happening further back in the head, so over more parietal or even prefrontal regions. But a cluster headache, generally, people described it as somebody trying to either force their eye out from the inside or push their eye in from the outside. There was always an eye facial component to it.
Yeah, distinguishing the two can be quite a headache.
Yeah, on the phone, yeah.
And I came across this condition, migraine with cranial autonomic symptoms. So migraine coming with the eye symptoms. It's okay. Okay. Let's dig down then a bit into what's driving this. And something that was quite new for me was the role of genes. And you talked about this hypocretin or orexin receptor gene, HCRTR2 gene. I know hypocretin with narcolepsy. I think most neurologists would know that. But with the link with cluster headaches, kind of new for me. Can you explore that a bit?
Yeah, now we're not there yet in our understanding of this. You know, it's we know that there are differences in terms of the concentrations of hypocretin, also known as orexin, as you know. But we also know that that gene has the power to alter the receptivity of the receptors for hypocretin. So that's also a modulatory factor. And I suppose one of the things that's really, really interesting about this is that we know that hypocretin is something that is involved in our satiety signals. Okay, so it's very, very active in the hypothalamus. And, you know, as we know, the hypothalamus has its fingers in all of our biobehavioral processes, but hypocretin is released in higher concentration after a period of food deprivation, but it also responds to taste incentives of particular foods. And I like to contextualize this in terms of this is something that can be overridden So say, for example, you've had a lovely meal and you're out and you're absolutely stuffed, and then the waiter comes along and says, would you like to see the dessert menu? And you think, well, you know, these people, they work really, really hard. It'd be rude not to look at the dessert menu. And then you see something that you really fancy, you know, I don't know, speaking from experience, chocolate fudge cake with Madagascan vanilla ice cream, maybe. I don't know. And even though I am actually sated and I don't need to have that chocolate fudge cake with the Madagascan vanilla ice cream, orexin or hypocretin has the power to override those satiety indicators reaching my hypothalamus. So I can find room. Okay, I can find room for that dessert. There's a whole other compartment in my digestive system for the chocolate fudge cake and the Madagascan vanilla ice cream. So we know that hypocretin has a major role in the reward system for substances other than food as well. So things like alcohol, nicotine, drugs like cocaine, for example. One thing that's really interesting is that the prevalence of smokers in people with cluster headache is really, really high. So it's 90% of male cluster headache sufferers will be smokers, and 70% of women. Okay, and there's similar proportions with respect to the alcohol intake as well. And so there is a way of looking at this that actually, instead of being really trite and saying, oh, well, smoking is causing cluster headaches in these patients, which, you know, that's not rocket science. You may say that because it's correlative. And also there are reasons why smoking may cause headaches. But actually, if we scratch that surface a little bit and take it back to why it is that people have become addicted to nicotine or have become addicted, let's say addicted to alcohol, it's because the orexin system isn't as effective, or the hypocretin system isn't as effective in those satiety signals, and they can be overridden. And so actually saying that smoking is causing the cluster headache is the wrong garden path to end up on. Even if you get people to stop smoking and they cease their smoking habits, that doesn't stop the cluster headaches from going away. So the cluster headaches are actually something else that are mediated by the hypocretin system. We're not entirely sure yet how, but the other behaviors such as smoking, alcohol dependence, those things are incidental to the hypocretin system, as opposed to driving the etiology of the cluster headache themselves.
So you could argue that if you can solve the problem with the receptor, you can actually solve the problem with the cluster headaches and the addiction.
Okay. Absolutely. Yeah, absolutely.
Interesting. I wonder if anybody has thought about using the drugs we use to treat narcolepsy with migraine, with cluster headache.
Yeah, I think it's being done, and also it's being done with respect to insomnia as well, and with some new, much more targeted drugs coming on the market that actually will affect such receptors themselves. And so I think there is traction happening there in those fields, which would be great.
That's translational neurology in action, science getting to the bedside.
Yeah, absolutely. And it's happened in the migraine literature for calcitonin gene-related protein as well. So it's just the next frontier. And I think that would change everything for cluster headache patients, because at the moment there's no easy way without side effects to actually prevent them from happening. There is a way in which you can arrest it from progressing, but only really if you take medication within the first hour of experiencing the headache or feeling the headache coming on. And people aren't brilliant at interoception. So people only know they're in pain when they're in pain. And something that I dwell on a lot in the migraine literature is that in migraine, you know, there are signs that you are undergoing a migraine experience sometimes 2 days in advance of actually experiencing the pain. And that was your window of opportunity to self-medicate or to medicate in other ways that you can actually redress those neurotransmitter balances. And at the moment, we're really, really bad at doing that as humans.
And there's always that expectation, isn't it, that this will not evolve into a full, let me wait and see.
Oh, we're very glass half full in that respect. We don't expect the worst thing to happen, which is very bizarre, when you think of like other ways in which we live our lives as societies. We do expect the bad thing to happen.
Hope trumping over experience, I think.
Very good, yes.
There was this quotation, I'm quoting you. Fluctuating light levels over the year might explain the periodicity of clusters. How does this mechanism work? Why does cluster headache cluster? I suppose that's the question. What has light got to do with it?
Well, light's so important in many of our rhythms, not least of which is our sleep-wake cycle and everything like this. But this is all ruled through the retinohypothalamic pathway. Now, it's really interesting because it's always been thought that there are non-image forming retinal ganglion cells. So these are the first place we get nerve cells in our eyes, takes the input from our eyes to our brain. And generally, we're talking about things like they're connected to photoreceptors, which tell us at a very early level, is it color or is it just light or dark? And they all feed into image forming in the visual system, which we're all very familiar with. And the visual system is probably the most over-researched system in the brain, but then that's probably because most of our brain is devoted in some way to decoding or acting upon our visual information. Now, so non-image forming retinal ganglion cells are things that feed information about light levels and modulate activity based on light levels in relation to whether or not it's bright or it's dark. And the most common way that we could contextualize this is not just in terms of our sleep-wake cycle, but in terms of actually even thinking about the hormones that are responsible for this. So we know that based on the light that's coming in through our eyes, if as light levels begin to diminish, our serotonin is converted into melatonin by our pineal gland. So if there's very bright light, then that serotonin is not converted into melatonin. Now, this is important for various reasons. But the main thing to say here is that this gives us that periodicity within a day to tell us when to go to sleep because we need melatonin for that, or when to be alert, we need serotonin for that. So that's one of the mechanisms by which we do this. Now, the suprachiasmatic nucleus is a part of the hypothalamus that sits above the optic chiasm, which is where you get that partial decussation of information coming from both of your eyes so that it can, in effect, be treated contralaterally. But the suprachiasmatic nucleus is really, really important in setting that biological clock. And it's different in males and females. It's more elongated in females than it is in males, even though the volume is the same in both males and females. And we know that sex hormones have an effect on that elongation, so through development. But we also know that testosterone is actually quite important in cluster headaches as well. Particularly a decrease in testosterone is coincident with people who experience cluster headaches, and they happen more in males than they do in females. So the suprachiasmatic nucleus is really, really important in various aspects of allowing our biological clock to function correctly. We have to think about each person's body clock and actually be able to scratch that surface. And we are doing this in medicine now because we know that actually some drugs, like blood pressure medication, for example, is better administered at those times of peak blood pressure measurement. And so we can actually mine this for its usefulness, bearing in mind that each person's body clock is going to be different. It's going to be regulated differently. We know that the suprachiasmatic nucleus is intimately involved in this. And of course, it being part of the hypothalamus, it's very, very sensitive to all of our hormonal milieu, including hypocretin, including testosterone, all of these things that have been coincidentally identified as being involved in cluster headache.
It's sounding more complex than the biology of migraine, I have to say. But
yeah. And again, as I talk about it, if we're talking about things like light, sometimes that is not in our control. This is part of a big compound of influences that need to be taken into account in cluster headache.
Okay, you've explained the male preponderance, I think, to do with testosterone and the suprachiasmatic nucleus. What about histamine? That's always been kind of there at the beginning with cluster headache. Is it? And I get the feeling it's still relevant. Is it even now?
Histamine? Yeah, I think it is still relevant. I mean, we have to think about histamine again in the wider context of what actually happens when our body feels under threat. Okay. And what happens when our body feels under threat is we have an immune response. And of course, the first line of defense is histamine release. And we need histamine because what it does is it makes our blood vessels dilate. It brings blood to the area that needs it. So it widens our blood vessels, dilates them. It makes them more leaky. So it means that big white blood cells and mast cells that have histamine in them can be released at the level of insult. So if there's damage or something there, of course, in the brain, that's much more difficult to handle because, of course, we want to keep blood separate to brain tissue. But ultimately, you need to protect that. And that's why we have this very early warning system, in that if you have a dilation that is natural because, of whatever reason, or because you have a faulty hypothalamus that isn't regulating the parasympathetic, sympathetic nervous system, you're feeling like your body understands that there is a threat and it releases histamine into the system because that's the first thing that the body does when it's under threat. But of course, then that sets up these nasty vasodilatory effects. And then our trigeminal nerve is on a hair trigger for this because it's watching for vasodilation in the skull because it can't have any of those blood vessels bursting, because then that means you've got brain tissue damage. And of course, that's hemorrhage, that's stroke. And we're going to know about that straight away. And also, given hypocretin's role in gating the activity of the trigeminal nerve, if we have less hypocretin, that tends to not be gated as well. So, of course, that all then feeds into the cluster headache presentation. So, various people have tried to treat cluster headache with antihistamines, trying to modulate the amounts of histamine that are actually naturally in the body hasn't had a huge amount of effect in the clinical literature. There's been the odd patient here or there that has been reported in great detail when they've been hospitalized and they've been given a certain set of drugs and a particular protocol to try to reduce headaches. But actually, even the authors would say, listen, it's most likely this is placebo effect.
Okay. That puts it in its place. And the other clinical feature, which I've kind of delayed until now with cluster headache, is the pupillary constriction, the tininess on that side. And this was picked up by Marcello Fanciullacci in 1979. Surely somebody would have noticed this meiosis in cluster headache before 1979.
Yeah, I think part of the problem, we go back to the fact that cluster headache was ill-defined really until, say, 1974 as being its own syndrome. That's 1974 is when Cluster Club came about. Okay. And so I think that there's a way in that people it's not that it wouldn't have been noticed before, it's just about people having the nerve to actually publish it. It's a little bit like Hans Berger and the etiology of the electroencephalogram. You know, he had developed this in his garage in Germany. And it took him 5 years to get the nerve up to publish it because he thought people were just going to laugh at him. But actually, people thought, I mean, we're talking, this is the 1930s, 1920s. You know, it's not really that long ago in terms of scientific discovery. But, you know, he didn't have the nerve to publish that for 4 years. You know, we see this over and over again. And again, it's like somebody first saying in the literature that, oh, oxygen is a good treatment for this. It doesn't mean that it hadn't been widely understood or even utilized before or noticed or observed before. It just means that it didn't hit the literature.
Okay.
Which again is a damning indictment on how it is we actually report our findings.
Yeah, I know that many neurologists kind of are surprised when something is discovered later on and they said, well, clearly I must have been seeing this in my clinic. Didn't take notice.
I think that the interesting thing about that paper was that it very much delved into why it is that might be so. And of course, knowing about the parasympathetic activation in cluster headache and linking that then to the teary eye or the pupillary response or the runny or blocked nose, and actually being able to put all of those things together within a mechanism, I think that's very powerful.
Okay, so you could give a reason for that. Makes sense. And then MRI, you talked about Rachel had an MRI scan.
Yeah.
And I'm kind of, my understanding now is anybody with a cluster headache needs an MRI. What's the yield, do you think? It's
I think that the main value for MRI in cluster headache is very much to rule out anything else. So like an aneurysm or something like that. The value of MRI in cluster headache is much more to rule out those other things. But actually, in terms of being able to look at a brain scan and say, oh, you're going to experience a cluster headache at some point in your life, that's not where we're at. And that's really interesting because anatomy tells us some things but doesn't tell us everything. And I think that's where, you know, as a neuroscientist, I very much sit. Anatomy is very important. Functional localization is very important. But what we now know is that it's actually how those regions talk to each other and how it is that how different areas become active, but how then they down the line activate other areas or inhibit other areas because of their activity. And that's the really interesting thing. But then that makes it much more of a complex system. And of course, there are scientists and clinicians out there who don't like complex systems because they're very hard to deal with. And what we need to learn is how to hold the uncertainty in our hands, but not be blinded by that complexity, and actually just keep plugging away in interdisciplinary ways to find a way to interact with the system and see if we can pull a lever to actually help things. But certainly, I think that cluster headache as a biobehavioral environmental condition, and I use environmental there in every way that it sounds, that we realize that actually it is at that very confluence of brain, behavior, body, and environment.
Complex.
Very.
So I will not be badgering my neuroradiologist colleagues to look at the suprachiasmatic nucleus for any.
Yeah, I think it's how it functions is the key, not what it looks like, it's how it functions. And until we can get a better handle on how that actually happens, then we're not going to make much progress. But I think, you know, we're on the right path. We're on the right path with hypocretin. We're on the right path with the hypothalamus. We're on the right path with testosterone, but trying to put all those bits together into a coherence. And again, this isn't something that is, we're going to have a general overview of how we think it's happening, and then we're going to have to test that in fully functioning humans. Because what we need to know is where are the limits of our understanding, and does our understanding of it, does that actually work for everybody, and where are the differences between various things, so like, sex, age, race, ethnicity, physiological background, genetics, where are all those levers, and what influence are they having? And that's really, really important, because if we can't find that out, we are constantly going to be stuck in a vortex of just helping some of the people some of the time. And we're not going to be efficient in how it is we're targeting our treatments for the people that we know, for whom we know it will work. That will then take us from helping some of the people some of the time to helping all of the people all of the time. And that's our utopia.
Precision medicine, I suppose that will come.
Absolutely. Yeah. Which is much catchier, I'll say, than what I said.
No. It's too complicated, but I guess that's where we're heading. It's somebody has a problem with the serotonin system, melatonin, and kind of teasing.
And we'll need data, and we'll need AI, and we'll need machine learning for that. But I think that's pretty much where we're beginning to get to. It's just we've got a number of roadblocks in the way,
which I'm sure we'll overcome.
Hopefully.
Okay. A bit of light touch neurology. You talked about the link between oxygen and the TV show Friends. Elaborate on this. I'm sure that's kind of caught listeners' attention now.
So, right. So, the TV show Friends had various characters in it, and the person who played Phoebe Buffay in Friends, Phoebe, is called Lisa Kudrow. And Lisa Kudrow's dad was a neuroscientist.
Okay.
And so he was one of the first to demonstrate that actually, and actually write about it in papers, that oxygen is something that can help with cluster headaches. So his Lisa's dad was called Lee Kudrow, and Phoebe worked with him actually for a while. So she has a biomedical degree, and they both suffer from cluster headaches. And so they were both interested in cluster headache, its etiology. I mean, we're talking the very early 1980s, so like 1981. And they actually published a paper together that you can find online in 1994, debunking the idea that at least in California, more left-handed people suffer from cluster headaches than right-handed people. So that's it. And I enjoy doing this. I enjoy bringing the things that people see as being very opaque, like science, but actually making links between your experience as somebody who used to sit down on a Friday night and watch Friends, and what it is that they're experiencing. Sometimes there's just little things like that. There's another person who supports the use of oxygen called Lance Fogan, and he works out of California as well. And in 1985, he made this link as well. He likes to point out the neurobiology lessons that are in Shakespeare texts. So if you look him up, you'll find a whole website that's devoted to the neuroscience of Shakespeare. Now, we've all heard about the neuroscience of Proust, but Shakespeare was new and on me. So that's another person who is interested in the role of oxygen in the treatment of cluster headaches.
Okay, and that's exciting. Okay, I wish we could end with a high there, but I think we just need to talk a bit more about the treatments of cluster headache. And lithium and verapamil, quite effective. How did we come by these two agents? Was it serendipity, or somebody actually thought about the science of it?
I think the reason why is because, well, certainly verapamil is a cardiac drug, and it reduces vasodilation around the in the heart musculature. In the cardiac blood vessel system, cardiovascular system, and so when you think about what it is that's happening in headache in general. The biggest cause of headache, except for in migraine, which is a little bit different in terms of its progression, its pathophysiology. But the thing that causes the pain signals to be sent to your brain is vasodilation. And we've talked about why that is, because you can't have vasodilation. You need a warning. And of course, that warning can be a very severe warning. And pain is a warning, right? You know, stop doing what you're doing. You're in danger. This tissue is broken. This tissue is about to break. You know, whatever it might be, anywhere in your body, that's what pain is for. And so anything that will reduce the dilation is seen as being helpful. And verapamil is one of those drugs. But actually, it turns out that verapamil has effects on the hypothalamus itself. So, you know, this is really handy because actually what it can do is it can change the effectiveness of the clock gene. And of course, the clock gene is one of the genes that's involved in our biorhythms. Okay, as the name suggests, but you know, there's lots of reasons why we would have that acronym for this particular gene. But yes, so it was a happy coincidence. You know, it is one of those things, and lithium in the same way. So we know that lithium also affects the hypothalamus. We know that it has effects on mood. We know that it has effects on boosting serotonin concentrations, particularly in the preoptic nucleus. And of course, in the preoptic nucleus, that's where we get the regulation of lots of our sex hormones. So that can have knock-on effects for our testosterone concentrations as well. So a lot of these things are kind of like, I like to call backward explained. So it's one of those things where you try something and then it works and you try to explain why it worked, you know, instead of the other way around, which is to try and predict what would work based on how it is you think something works. And so, as you say, lots of serendipity there. But again, Lee Kudrow was involved in the administration of lithium in cluster headache as well. Showed dramatic effects in the recurrence of clusters in 27 or 28 patients. So, you know, that's great, but lithium is actually, you need to have a very precise control over the dosage of lithium because it can cause all manner of other things, like blurred vision, balance problems, full-on convulsions, and also people tend to adapt to the dosage, so they need ever-increasing doses. And I think that's one thing to think about in terms of certainly verapamil and lithium, is that physiologically, you're entirely different to the person that you were yesterday, you know? And that has to do with how much light you had on your retina. It has to do with how active you were. It has to do with what you put in your body in terms of what you ate and what you drank. And your physiology is ever changing. And so really, when you have a stable dose of something, it doesn't actually mean it will always be that way. It will change throughout your life course, because as your body and your tissue change with age, as your receptivity to certain drugs changes, as your behaviors change, that will change everything. And so you cannot think of yourself as a physiological stable being. You're not.
And that's why we keep increasing the doses of all these medications as we go along.
Yeah, absolutely.
Well, with lithium, also the toxic level is so near the therapeutic level.
Bring
it.
Risky.
Yeah. Okay, another catchy bit of the chocolate, sex, and coffee. You said that's the title of one of the chapters.
Yes.
And those are things that help cluster headache. Is that so?
Well, okay, so let's think about this from a biological point of view, okay? If we think about coffee, it is a vasoconstrictor. So if our main problem is vasodilation, you know, this is why oftentimes with certain drugs like paracetamol or acetaminophen, you'll get them co-packaged with caffeine. Even with ibuprofen, you'll get them co-packaged with caffeine so that you have the double whammy. Not really necessary. You can just take 2 paracetamol with a cup of coffee, you know, actually with water, and then with the cup of coffee as a chaser, because paracetamol tends to dissolve in coffee, and that's just disgusting. Nobody wants that in your mouth. So take them with water and then have some coffee. Some people take them with say a caffeine drink or something like that. The problem with particularly the drinks, the caffeine-laden drinks and the energy drinks that people take is that addiction is always prevalent. And why do you get addiction to that? Well, because actually you're vasoconstricting your vascular system. And then, of course, if you go, say, for example, 2 hours, 2.5 hours, 3 hours without your coffee fix or your caffeine fix, your energy drink fix, you get rebound vasodilation, and that causes a headache. So you go, oh, I'm getting a headache. Oh, I'm due my energy drink or whatever it might be. And that's addiction, right? Because that's a withdrawal effect. And that's a big, big part in addition to tolerance that we see in addiction. But anyway, so that's why coffee works. Chocolate, okay, so chocolate certainly in the darker chocolates, but it actually works in milk chocolates as well. Chocolate is full of tryptophan, which is a precursor to serotonin. So when chocolate is broken down in your body, it actually converts into serotonin, which of course we know is a big mood regulator. And as we've talked about, we do know that there is a role of serotonin to play in both cluster headache and in migraine headache. Anything that engages the hypothalamus, we're going to have serotonin at play. So we can self-medicate that way and boost our serotonin levels that way, particularly if our serotonin is being converted into melatonin, or if we have low serotonin to begin with, so that we can't actually convert it into melatonin through perhaps our hypocretin or our pineal pathways, our suprachiasmatic pathways. So it feeds into various aspects of this story, and you can self-medicate with chocolate. And of course with sex. Sex is a huge neurobiological undertaking, of which there are various aspects, and you get boosts of serotonin, you get boosts of oxytocin, you get boosts of dopamine, and actually these three are the natural painkillers of our body, so they actually do gate the signal of pain to our brain, and of course if they're being created by our brain, then that's where they're going to work. So it actually reduces the amount of pain that we're going to feel. And so it's interesting. There isn't a lot of research on this, and there are some people who develop sex headaches because of the spike in blood pressure and the vasodilation of the head and neck. So there are some people who develop sex headaches, but there are some people who will self-medicate with sex. We see it more prevalently in the prodrome phase of migraine, where people's desire scores increase because they are actually trying to self-medicate, and that's why people have sweet cravings or chocolate cravings in the prodrome phase of migraine as well. They're actually trying to self-medicate. So it's about trying to take these syndromes or these influences that we know exist and trying to mind them. But again, interoception is really important. People need to know when a cluster headache's coming on, and I don't think that people get that much warning before it actually hits with cluster headache, in contrast to the migraine. You do get quite a lot of warning, but most people don't recognize it.
Okay, 3 things that are unlikely to be on my prescription pad.
But, if you could send people to a place where there's lots of light on the NHS, that would be amazing. I'd buy into that.
Ways around it. Okay, and with what's next? You talked about deep brain stimulation, mainly with migraine, but apparently something promising for cluster headache as well?
Maybe. We're at the early days of this for cluster headache. It may be that we can find a way of actually changing or modulating the electrical activity that we see at the level of the cortex, perhaps through something like transcranial direct current stimulation or transcranial alternating current stimulation, and this has some efficacy for depression, for example, where if we can find a region in the cortex that is, for example, receiving sleep-like signals from the thalamus, because that's what seems to be happening. that we can actually pace those in a different way and hope for some kind of like long-term potentiation along the way and actually modulate those signals to have traction over a longer period of time, not just when you're actually receiving the stimulation. I think we're a bit off that yet. I think it's an invasive, certainly deep brain stimulation is invasive. It's much more targeted now than it ever was before, because we can have online MRI during operations, during procedures like this. So it's much, much better than the 1980s. But I think that for something that is so ill-defined, has the periodicity that it does, I think we probably need to understand a lot more about its periodicity, about its etiology, about what makes that different for different people, depending on lifestyle components, depending on environmental components, depending on that biophysiological pathway that's different for all of us, and also the genetic link. I think we've got a little bit more to do. I don't think that brain stimulation will be in the same situation as, say, verapamil, where we might say, oh, let's try this and see if it works. I don't think we want to be doing that for deep brain stimulation.
Well, maybe the hypocretin pathway will give us solutions that would not need to.
I agree.
Easy. Okay. Neuroscientists are not likely to be out of a job for a very, very long time. What project are you working on at the moment?
Because my major interest is in how different regions of the brain communicate with each other and how it is that brings about our experience of life.
Yes. It
means that my fingers are in lots and lots of different pies. So I have a few fingers in neurorehabilitation. So in terms of how to restore function to patients, particularly who experience visual loss following brain injury. And there are ways of doing that if we understand the basic communication of regions that bring about normal function. There are rather simple effects, rather simple things that you can do. For example, in things like hemianopia, you can train people to move their eyes, because it turns out they don't move their eyes. But if they move their eyes, the blind field would be in their seeing field. And of course, you can actually train people to do that. So years upon years upon years of my research of sending magnetic pulses into different parts of people's brains have now finally come to fruition in terms of understanding that we can actually just have a behavioral training program to actually help these people see their worlds more. And some people get their driving licenses back, which is phenomenal success for a program such as that. But it also means that I'm involved in concussion research and transient brain injuries. So that's put me into the sporting realms as well. I'm interested in how different parts of the brain communicate in order to bring about our internal body experience, so interoception, but also in terms of our inner voice. And that then brings me into audioverbal hallucinations and things like that. I'm also interested in ventriloquism and the ventriloquism effect. So it actually makes me sound scientifically promiscuous in that I'm interested in lots and lots of different things. But actually, it all comes down to, if you have a knowledge and an understanding and an expertise in how different parts of the brain speak to each other, and a good understanding of the neurobiology and physiology that underlies that, and you can have that laterality of thought to think about how that then affects the body and how that then affects your behavior and how then that feeds back to affecting your body and your brain, then that's something that actually gives you traction in social problems like air pollution and brain function and lots and lots of other things that I've found myself involved in.
Well, the common theme is that they all have practical applications, which is the important thing.
This is the key. We need to be able to translate what it is that we're finding for the common good. Otherwise, basic science has its place, and it may take 15, 20 years to translate, but you always have to have your eye on that ball, because you need to encompass all of those people who are going to be affected by that into your earliest inquiry to make yourself more efficient and targeted.
Okay. Last question. Any books you would like to recommend, either on this theme or the brain generally?
Well, it's interesting. I have read many books about the brain, and it's actually the reason why I wrote my first book, which was Getting Your Head Around the Brain. And that's mainly a book to help people understand just how their brains work in a very overview type way, but very much linked to behaviors that we all carry out, and to link what's actually happening in your brain to bring about those behaviors. So there's that kind of approach, but those other approaches do have their value. They have their value for bringing people into the story and into the fascination, and they can be almost infectious. Like Oliver Sacks is really good at this, right? And I know he's got posthumously a new book out around his letters that I'm very interested in reading. But he's really good at describing fascinating cases, like the man who mistook his wife for a hat stand. But I think that there is a gap there in terms of being able to take that forward and say, right, okay, here's why that was happening, and here's what happened next. This is how we dealt with it. So V.S. Ramachandran's really good at doing this. So like he works on things like phantom limb and synesthesia and all of those really, I'm going to say cool. They're not cool for the people who actually experience them, but they are fascinating. And so I like to read books that grip me by their fascination with their quest to understand what's going on in our internal lives, and how that then might marry up to other people's internal lives. And it gives us a much better understanding of other people, the constraints under which they're working, and also how it is we may better interact with them.
Oliver Sacks, Ramachandran, and then Getting Your Head Around the Brain. I have to take that.
Enjoy.
Amanda Ellison, thank you very much for participating in this episode of the Neurology Lounge podcast. I'm most grateful. You sacrificed your time for this. And to my audience, thank you very much for listening or watching the podcast. If you enjoyed it, you might want to have a look at my own book after reading Amanda's book. It's called Surfing the Brain. And I have a neurology database called Neuro Checklist if you want to have a bit of the hard bits of neurology. And to make sure you don't miss the next episode of this podcast, you might want to subscribe to the YouTube, iTunes, or Apple channels of the podcast. But until the next episode, thank you very much for your time. And Amanda, I'm very grateful for your time as well.
It's been an utter pleasure to be here. Thank you.